if you remember, hello. Okay, we're working with exponential functions. Y'all remember those? The general form is this f of x equals a times b to the x. So we had y equals a times b to the x. Yep, remember that? Okay, so we're doing that. The parent function, so the most simple version of this is anything that looks like this. F of x equals bcx. So we can plug in numbers for b. The most standard one is going to be 2, because if you remember, we can't have b equal 0 or 1. So 2 would be the next one. All right. We're working on translations and all that. So for general form, we add in the a. Y'all remember adding in the a? What does a do to a graph? Same A as before.
It shrinks or stretches.
Stretches and shrinks it. So factor A stretches. Yes, stretch. How do you spell stretches? That's not good. There we go. Stretches, shrinks, and or reflects. Y'all are on it today. The parent function, okay? Okay, we're gonna start out graphing one where the a is less than or between 0 and 1. So what does that mean? A shrink. Okay, so this is going to shrink. All right. We're actually going to graph 2 of them at the same time so that we can see the reflection as well. So we'll graph this one with a positive 1/2 for A, and then this one with a negative 1/2 for A. And the x's we're going to plug in. Let's start at -2, and we're going to go all the way up to 3. So how do y'all want to do this? Do you want to work it out in your head, on your paper, or look at it on the graph, or look at a table in the calculator? What do you want to do? Calculator. You can either put all this into the calculator and replace the x with whatever value you have and get the answer, or you can put this in for y equals and go look at the table. Either one. So what do you get when you plug in -2? Does anybody have that yet for the first one?
Yep.
0.125, which is 1/8, I believe. That's a 2. Okay, what would happen if you put in the other one with a negative? If you put it in over here, it's just negative times this, right? So you'd get -1/8. Very good. Okay, go fill in that whole chart, and then we'll... All right, your chart should look something like this. Okay, get it? Okay, so let's graph it. You can put your axes pretty much in the middle of the graph for this one. So, something like this. Okay, their axis, and then... So at -2 we need 1/8. So -2 and 1/8 is just going to be barely above the line. Pretty close. And then we also need the -1/8. And then for -1 it was a 4, so a little bit above that. Not much. Oops. Wrong color. For 0, it's a 1/2, right in the middle. 1, 1, 1, -1, 2, 2, 2, -2, 3, 4, and then 3, -4. You kind of get the shape of the graph. So for the first one, the positive one, what was the y-intercept? X equals a half, what was the a value? So those are the same. Okay, so for the negative one, what was the y-intercept? Negative 1/2, which is the same as the a. Not x equals a half, that's supposed to be y. Huh? Okay, talking about the y-intercept, so like this point right here, that's a half, which is the same thing that the a value was, a half.
Okay.
So the a gives you the y-intercept on this, on these. What's the horizontal asymptote for these? Is it the same?
Yeah.
What is it?
For the top one, it's y equals 0, I believe.
0, yes. It
I
gets
guess it is the same.
closer and closer to 0, but never touches it. The blue one, the bottom one, is the same. It just comes from the bottom side of it. Ha! I say that's sorry. I write that instead of horizontal asymptote. It's a lot shorter. Okay. Any questions? All right. So now we're gonna add in the h and the k again. Yay! They're still weird. H is still weird and backwards. K is normal. Okay. H is still attached to x, so here it's in the exponent. K is what hangs off the end. The tricky, weird part of this, it just happens. It's not anything different. It just happens. Is that the h, when it moves horizontally and vertically, because of the shape of the graph, it causes the same thing that the vertical stretch/shrink causes. Like those look the same on the graph. Those kinds of changes just because the shape of the graph. Because it's that one-sided curve. So, and you can see it in the equation because those are the properties of exponents, that b to the x minus h is the same thing as b to the negative h times b to the x, because we just add those exponents. Okay, so that's where mathematically it's the same as the stretch or shrink. This isn't something that you have to like do, it's just something that happens, okay? So y would be properties of exponents / the shape of the graph. I'm just going to write properties of exponents. Okay, and then the k, so k shifts a graph up and down, right? So what that does is it also shifts the horizontal asymptote. It's a vertical shift of the entire graph. So that means it includes the asymptote as well. Okay, so like if our thing was out here, it'll go up h units. The asymptote just moves up with the graph. This italic part, it's just a summary. It's saying, it's like we've done before, h is stuck right there with x. K is always on the end, and for this, h is the horizontal shift and the vertical stretch shrink. And like I said, that's not extra things you need to do, it's just what it is. And the vertical shift of the graph moves the horizontal asymptote as well. Okay, we good? It's kind of... All right, so let's practice shifting these. The easiest way to do it, instead of... you can do it in your calculator, but what we're going to do is graph the kind of parent function of this specific equation. So here's our complicated one. Here's the simple one without the h and the k. We're going to graph this and then shift it in order to get the other graph. Okay, so we're going to start out with this one. So what x's do you want to plug in? We probably need 4 or 5. What do you... Yeah, -1, -2, 0, 1, 2, 3. Okay, so plug in -2 for the x. So for this x right here, and what do you end up getting? 32. All right. What do you get when you plug in -1? Uh-huh. What comes next? Uh-huh. Yeah. Remember that growth factor or decay factor, so this one's a decay factor, tells you kind of what pattern happens here. So we went from 32 divided by 2 all the way down until we got 1. Okay, so let's graph that. Put your x-axis down at the bottom and your y-axis can be in the middle.
You asked Sam if he was okay.
I messed it up.
What's that supposed to be?
You're insane.
Okay, so let's see, how should we do this? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, I don't know. Okay, I'm just gonna make the by 4s. Okay. So 4, 8, so that'd be 12, 24, 36. Okay, so 32, -2, 32 will be here. -1, 16, be there. 0, 8, 1, 4, 2, 2, 3, 1, something like that. Okay, that's the original one. That's y equals 8 times a half raised to the x. Okay, to graph the other one, the more complicated one, we just need to know the shifts. What did the h cause? Left 2, very good. And the k? Yes, up 3. So take each point and do exactly that. So I'm going to take this point and go left 2, up 3. That's the new one. Take the next one, left 2, up 3. And the next one, left 2, up 3. Next one, left 2, up 3. Intersected. 2, up 3. 2, up 3. So in the horizontal asymptote, what was the horizontal asymptote for the first one? 0. So what's the new horizontal asymptote? 3. So I'm going to draw a dotted line just to make it clear there. And then complete my graph. Which I kind of missed the curve. That's okay. Okay, so this one, the horizontal asymptote is y equals 3. The first one, horizontal asymptote was y equals 0. So what part of the equation gives you the horizontal asymptote? The k. Whatever is hanging off the end, that's your horizontal asymptote. If there's nothing hanging off the end, then it's 0, which is everything we've done so far until this problem.
Wait, what do you mean that was hanging off the end?
Like this, the 3, there's just a number at the end of the equation by itself. Yeah, so that 3 is your horizontal asymptote. Any questions on graphing these? No? On your homework, I think it only gives you like the complicated one, but it wants you to graph both of them. So just take off the h and the k, if they're both there, graph it that way, and then move it over. Okay, one last part.